Hello again, time for the second of the naming videos. Keeping it fairly simple for the start of your organic chemistry, and going to look at some of the compounds that didn't look at in the first naming video. Start with some alcohols. Shouldn't be too difficult to name them first two. One carbon, we should know by now. It's going to be based around that, but the question is, how do you put the name together? Well, you need the AN in order to construct an alcohol name, so that then becomes methanol. This business of do you have the AN, do you just have the meth, or do you put the E on the end as you do sometimes? It's just a minefield. Really, I can only suggest you just do enough of them that you remember them, because that's what I do. So, 2 carbons, ethanol, not dissimilar to anything you would have met before at GCSE. When we get to this one, GCSE would call that propanol. It's not really the right name, because propanol comes in 2 isomers. Propanol comes in, there's the 2 carbon chains. One of them comes with the OH on the end. On the end is called terminal. And that's a word that I will mention a couple of other times probably during this video. Terminal. Terminal means it's on the end carbon. And there are some functional groups that are always terminal. Carboxylic acids, aldehydes, we'll look at some of those another time. Aldehydes we'll do later today. And when you have it terminal, that's fine, and it's all good, and it's forgot to put the number in. It's propan-1-ol to say the alcohol is on the end carbon, because the carbons are 1, 2, 3. This one here has it on the middle carbon, not surprisingly. Propan-2-ol. This is where the Americans don't agree with us in how we name things. They call that propanol, they call that isopropanol. Propanol. Oh, just irritating. Right, so there we have it. This GCSE named butanol, 4 isomers. Now I'm going to ask you to pause the video and have a go at drawing out. You don't have to do them skeletal. I would encourage you to, it's so much quicker. But if you want to do them as displayed, I would say that's probably the only other one that will help you. Come up with 4 isomers. And when we come back, after you've paused me, I'll have the answers on the board. See you in a moment. So there we are. 4 isomers. I've done them skeletal because that's my preferred thing. Terminal OH, butan-1-ol. Second carbon in, butan-2-ol. If you put it on the 3rd carbon, you just renumber it from the other end and it's still butan-2-ol. So there's no such thing as butan-3-ol or 4-ol. Nonsense names. Then, this is where you need to be a little bit more aware. You need to branch the carbon chain, so you get a propanol. You get a propanol with a methyl group. I was going to say propane, but it's not propane. So here you've got the 2 branched chains where you've got propane at the heart of it, and this is 2-methyl propan-1-ol because the OH is on the end carbon. Sometimes people say, does it matter which way I draw it? No, it doesn't. You could have just easily have done the OH over there, but there was a little less space, so I put it on the other side. And here you have the OH on the central carbon, so there's no hydrogens on that central carbon at all, and it's 2-methyl propan-2-ol. Now, when you look at these, there are also some other words that you need to be fully up to speed with. This would be termed a primary alcohol. Primary meaning there are two hydrogens when I put those two dots. So what that means is that there's only one, this is a carbon here, there's only one carbon attached to that carbon, it's primary. This here is secondary. So when you look at that carbon there, it's attached to that carbon and it's attached to that carbon, two carbons, secondary, not surprisingly. And this one is primary, because this carbon here is attached only to this carbon here, which makes it primary. But the one on the other side, never write and talk at the same time if you're me. You have to imagine I wrote the word primary correctly. This here, the carbon at the centre there is attached to 1, 2, 3 different carbons, so this is not secondary. This is tertiary. So there is also, apart from alcohols and the naming of, you also need to get up to speed with this idea of primary, secondary and tertiary. It doesn't only apply to alcohols, it applies to halogen containing compounds as well in organic chemistry. But that's those. I just need to do a little bit more about alcohols because I want to do what are called diols and how you name those. And then we'll move on to another functional group completely. So I'll see you in a moment when I've got the board ready. Just a couple of diols. Diols meaning di meaning two alcohols. Now, deliberately drawn that incorrectly. I don't mean it's the wrong compound, but that is not a displayed formula. It's only a displayed formula if you put the bond between the O and the H. Classic way to lose a mark if you're asked to do a displayed formula. There's its skeletal formula. Doesn't matter whether you put the OH down the bottom because single bonds can rotate. So it's called ethane 1,2-diol. It's an irritating moment again because in single OH group alcohols, that E disappears. So you get ethanol. Now you've got ethane 1,2-diol, so you've got the E back in. Just got to get with it. So there's another diol. Now I want you to think, what would the name be? How many carbons? And then what would the name be? Have you thought of it? The answer is 3 carbons. 1, 2, 3, because there's no carbon there where the OH is. That's a bond from a carbon to an oxygen. This is a carbon to an oxygen bond at both ends. So that makes it based around. So OH on the 1, OH on the 3, diol. There's also triol, 3 OHs, very important molecule. Propane 1,2,3 triol. It's the alcohol that goes on to make fats and oils in nature that we use for cooking. But we're going to move on to the next functional group, so I'll see you when I've got the board ready. See you in a moment. So we're just going to have a little go at some alkenes. We did some alkenes in the other video. What's the name of that? See you in a moment. And there it is, 2-methyl-hex-3ene. 6 carbons in a long line. Remembering that 1, 2, the alkene group goes between carbons 3 and 4, so it gets the number 3 because it's the lower of the two. And the methyl here is on carbon 2. So there we are. Now, what happens if there's 2 alkene groups? So, important industrial chemical that. Diene, as it is called. So just have a look at the namings for dienes. So how many carbons? 4. So the assemblage of the way to put the word together. numbering 1, 2, 3, 4. It's the same if you do it the other way. Butyl 1,3-diene. Okay, so your turn. I'm going to pause the video, have a go at naming that, and I'll see you after you've had a little go. So it was 6 carbons, positions are 1 and 4. If you number from the far end towards me, the double bonds begin on carbons 1 and 4. So there we are, hexa 1,4-diene. So the protocol is that you put the A after the but, so it's not but 1,3-diene. Would an exam board mark but 1,3-diene wrong? Difficult question. The proper IUPAC name does have an A in it. Right, we'll then move on to another functional group, and I'll see you in a moment. Amines, next functional group. So I'll do it the other way around because it's better to do both. 1-aminobutane, that is the way you put the name together. So amino means NH2. We obviously now know what butane means because we mustn't forget these things. So it would be there. Butane with one of the hydrogens replaced with an NH2. And there's the skeletal version of 1-aminobutane. See how much quicker that is to draw. Always remembering that that bond there doesn't have a carbon on the end because it's got a nitrogen instead. Now here's 2 that I would like you to have a go at naming. So I'm going to get you to pause the video and, well, see what you come up with, and I'll see you after you've had a go. So there we have 2 names, 2-methyl 1-aminobutane. Why? 4 carbons. Number them for you. 1, 2, 3, 4. So the amino group is on the first carbon, making it 1-amino. 4 carbons, that's 1-aminobutane, and then there is a methyl group on carbon 2, so it's 2-methyl aminobutane. Second one, aminocyclohexane. No number. I would imagine a number of people might well think, oh, I need to put a number in. But there's no conflict about where to put the amino group when you do it aminocyclohexane. It doesn't matter which carbon you put it on, it's all exactly the same, it's just rotated. So there is no requirement for a number. I will see you for the next functional group. See you in a moment. So now, not necessarily a functional group you'll meet quite at this point in your A-level course, but need to do the naming at some point. Just going to put lots of naming things in the same video. Ketones. Now ketones contain a non-terminal, that's not right, non-terminal C to double bond oxygen, which goes under the name of carbonyl. Now non-terminal, oh I've said it again, means there are carbon chains either side. Now you've not seen me do R. R represents rest of molecule, so there is carbon chains on either side of that represented by the R. They do not have to be the same, so you often represent that they are not the same by having R with a little mark next to it. It's called a prime, and so you get ketones where this functional group is in the middle of the carbon chain, like it is here. This is the smallest ketone you can have. You can't have one with 2 carbons because there isn't a middle carbon because they're both on the end. So there is an alternative way to do the molecule in terms of isomers, that is where the carbonyl becomes terminal. We'll do those in a minute. We'll just do these ones first. So this goes by the name of propanone. So propan, not prop, not propane, propan. It's all part of that. Get your head around it thing. So no number required because you can't be anywhere but on the middle carbon when you're ketoning, which is what ONE means. This one here also doesn't have a number. This is butanone. You will see it written as butan-2-one by numerous people, but there is no butan-3-one, because if you move it to the next carbon, you just number it from the other end and it's still on the second carbon. Therefore, there's no need for a name with a number. So, time for you to have a go. There's two things here. There are two isomers of the next one, which is 5 carbons but still a ketone. Draw them out, give them a name. And then have a go at the name of that down there. I'll see you after you've had a go. Pause the video and have a go. See you in a moment. So there's the answers. Pentan-2-one and pentan-3-one. No such thing as pentan-4-one, it's pentan-2-one, which is the right name. I've stopped mentioning the commas and the hyphens that you need to remember to put in. Going from a letter to a number is always a hyphen in either direction. Just a little bit of an aside. For the Star Trek people among you, some people call that Klingon bird of prey, but it's not, it's pentan-3-one really. And the name of this one, 2-methyl with a 2-methyl hexane 3-one. We're going to move on to the isomer of ketones that you see and do a little bit of naming of those. Nearly at the end. I'll see you in a moment. So the isomer is going to go under the name of aldehydes. Exactly the same molecular formula, they genuinely are isomers, ketones and aldehydes of each other. Here is 3 different ways of drawing out, but actually I know there's 4, but I'll mention that, I'll come to that in a second. There's the structural formula, CHO you write for that, not COH. If you write COH, people will think you've written an alcohol. We don't want that. So there's the displayed formula with the carbonyl terminal, it's on the end of the molecule, with the hydrogen next to it. Now the proper skeletal formula is that, because we don't put any hydrogens in skeletal formula, but most of the time people do this to remind themselves that, oh, we are talking about an aldehyde with the hydrogen on the end. Part of it is that this hydrogen is where, well, in terms of the chemical reactions that you can do, I know we're not doing chemical reactions, but it's this hydrogen and there that often do the chemical reactions, so it kind of gets put in. Technically not right, usually what you see drawn, technically right, either is acceptable. So I'm going to get you to pause the video in a moment and have a go at what we've got here. Draw out, in whichever way you like, the structure of ethanal. Remember, it's Al. Al meaning aldehyde, not OL. And methanal. And methanal, got to think a little bit about methanal. It looks a little bit unlike all the others. And then have a go at naming. Something you'd find on a cave painting, quite frankly. But have a go at what's the name of that. Pause me, and when you've done, unpause me, and you'll get the names. You'll see the names. See you in a sec. There we go. So I've drawn out displayed formula for ethanal and a displayed formula for methanal. It's the only one that has 2 hydrogens attached to the carbon, so it kind of looks like a really small molecule. Long and checkered history with methanal. It used to be called formaldehyde, which is something you may have heard of, but its name is now, in the UK at least, not in America, it is methanal. And this one, 1, 2, 3 methyl groups, 4 in a carbon, 1, 2, 3, 4 down the carbon chain. Now the aldehyde group, by what's called priority, and I'm going to do a little bit about priority in a moment, has to be carbon 1. So there they go down the chain. So it's 2, 3, 3. It's trimethyl. Don't forget to put the tri in. If there's 3 methyls, every one needs to be firstly getting a number. So that's why there's 2, 3, 3. It's not 2, 3. Because you know they're both on 3, but the name doesn't. You really to say 2, 3, 3 for each methyl, and say it's tri to say there were 3. And there's methyl and it's butanal. Right, a little bit more to do, not much, and we'll be done. See you in a sec. Quick bit about the last functional group we're going to put in this part 2. There isn't a part 3, so you'll be pleased to know. Carboxylic acid, again a functional group that appears a bit later in the course, but we're just trying to put all the naming stuff together. Carboxylic acid functional group, firstly, is always terminal, because of what you have as the structure, it has to be on the end. COOH, sometimes written as CO2H. How many carbons? 1, 2, no, there are 3, because that's a carbon as well. So that is going to be based around prop, but it's propan again, part of that. Got to get to know it. Propanoic acid. The next one, 2 carbons. Is ethanoic acid, something you're familiar with because it's vinegar. And there's a displayed formula for that showing you carbonyl and then C, and then, so that COOH is structured like that, put together like that. Here's a skeletal formula. You do have to put the O in this time. You have to put the O in. Of course you do. You have to put the H in as well, which is what I meant to say. You have to put the H in as well. So what do you think the name of that is? It shouldn't take you very long. Have you done it? Count our carbons up. 1, 2, 3, 4, 5. Pentanoic acid. I've just got one little more thing to say, and then you can get on to the follow-up questions. I'll just get the board sorted for that, and I'll see you in a moment. So just a little bit about priorities. There is actually a huge list in the IU pack, naming rules of which functional groups are above which ones in priority. Doesn't really feature that much in A-level, fortunately, but there's a couple of things. It's kind of almost obvious, because if you look at this structure here, the priority system says the alkene group has a priority over the halogen. It's kind of really which is the most important in terms of the chemistry that it will do. And although this will do chemical reactions, this does much more easily to do. It's much more easy to get it to do chemical reactions. So it's kind of going to be that. So that makes this an alkene, not a halogeno compound to start with. So the name for that will be 1, 2, 3. So it'll be 3-bromo pent-1-ene. So it will not end in ane to say it's a bromo compound, because it's unsaturated. The unsaturated has a higher priority. So 3-bromo pent-1-ene. Here, the acid group, the carboxylic acid group, has priority over the OH. So this is 2-hydroxy. Now we've not had hydroxy, because normally hydroxy would be in a compound as an alcohol, and you would just name it an alcohol. But here, this is not as high priority as this one. So it's a carboxylic acid, 5 carbons, so that's pentanoic acid, shoddy C, hope you noticed. And so 2-hydroxy pentanoic acid. The lactic acid thing in your muscle in cramp is also a hydroxy carboxylic acid as well, but not as big as this one. So when you look at that, this is a carboxylic acid, not an alcohol. That's what priority is about. Almost common sense most of the time, because you tend to name it for the things that are really obvious first and then do all the bits that stick off of it, which is kind of what happens anyway. That's it in terms of going through all the various examples. There's going to be some follow-up questions like there was to the naming part 1, which I'd like you to have a go at, and the answers will be there as well. Thank you for watching, and I'll see you for further adventures in our organic chemistry very soon. Thank you very much. Bye bye.